Yeah. How you doing?
Pretty good.
Pretty good, pretty good.
Are you able to edit afterwards?
Yeah.
Because I have no idea.
The world's been waiting, where were you? Everything you want, where
How are you
are
gonna help me?
you?
I've been reading the text, but I'm so confused.
Go to a tab and put tricky media in question. Just go to a tab.
Go to a tab.
Just put tricky media in question.
Are you able to see everything that I'm doing?
Yeah.
Oh. I better behave.
Now see that question on the left? That video?
This one?
I made that video.
Oh, this is you.
Yeah.
Okay, so this is a tricky median question. So let's go ahead and read this. The median for the given
Is that your
set
question?
order data value.
Is that my question?
Is that similar to your question? Let's see.
Very similar.
It is, huh?
Yes.
It's funny, huh?
Yes.
Is 28.5, and we have some values here and a missing value.
Mm-hmm.
So we do know the median, we just don't know the missing value. Below here it says that the missing value is 3.5. We can ignore that. That's the wrong answer, so ignore that. One important thing to notice is that this data is ordered.
I made this video like 2 years ago.
We really
you've
couldn't
been
do
using this
problem.
forever,
If we
huh?
had a missing value and
Yeah.
no,
I don't like this video, but whatever.
this problem wouldn't be
It's
possible.
exactly what I need.
Okay, so, but the data is in order, and the ordering is important because for the median, we want the middle two values. And notice that the middle two values are right here, 25 and our missing value. Another thing to notice is that we have an even number of values, so in that case, we need to divide the middle two values by 2 to get our median. So what we can do is we can create a variable for a missing value and just plug into the median formula. Let's do that. So we get 25 plus x divided by 2 equals 28.5, the median. Now from here, we'll solve for x by multiplying both sides by 2. The 2's cancel. We get 25 plus x equals to 57. Therefore, we find our missing value. I believe it's 32. Let's see, 57. Yep. And that's how you do it.
I kind of went fast.
You make it sound so easy.
I kind of went fast, but
No.
if you want, you can go back or something.
You make it sound so easy. Okay, so
So same thing here. There's 6 values.
plus x divided by 2 equals 31.5 divided by 2 to cancel also. I'm 63.
What'd you get?
63? I don't know if I'm doing this right.
63 is when you multiply by 2, now you have to subtract 27. Remember, it's 27 plus x divided by 2 equals 31.5. So then you multiply both sides by 2, you get the 63, right?
36?
And then when you subtract, yeah, you
Okay.
subtract 27 from 63. So for on this one, same process, right?
Wait, is this the one that
I don't know.
exactly the one that you did?
I don't know. Is it?
I think so. 5. It's exactly the one you did.
No way.
Yeah.
28.5 times 2 is 17 plus 40. 57 minus 20, 37 minus 5, 32.
Wait, what? 3.5 times 57. And open up. Oh, you're so smart.
No, the video is, I'm not smart, it's the video.
Oh, wow.
So you know the process now?
I understand that first question, yes, now.
For the mode? Is this asking for the mode?
Yes.
The mode would be the number that occurs the most.
And it does not exist because there's no repetitive one, correct?
I think you're right. I don't think there's a repeating number, so you can just say no mode. Yeah.
Yeah, that one is correct. Okay. I have a lot of them.
Okay. Let's see.
Let's see. Surf has the mean height of all 15 students in the class to be 67. Just as Mr. Surf finished, explain how to get the mean. Explaining the mean is 65.4 inches tall. What is the height of the 16 students in the class?
Any way to like increase the font of this question? By pressing like Control plus or something?
Control plus.
I don't know if that'll work, maybe. If not, it's okay. Just might be cool to see the better, like the font was a little bit
Really
bigger.
small?
No, not too bad. It's not too bad.
It's not working. Huh?
Yeah. Oh, you know what? Are you using Google Chrome or Safari or what?
I am using Safari, yes.
Safari. On a PC?
On a Mac.
Oh, on a Mac. Okay, then I don't know. I really don't know how to use those. So, so on this question, what do you think? It says there's 15 students that have a mean height of 67. Now, that means that the sum of the scores of those 15 students. Now, the formula for the mean is that you add up all the scores and divide by 15. Because there's 15 students, right? You add up all the scores. Imagine there's 15 students.
Mm-hmm.
You add up all the 15 scores and divide by 15. That's how you get the mean, right?
Okay.
That's the formula for the mean. If there's 15 students, then you add all their scores, and then you divide by 15.
Okay.
So you got to kind of memorize that formula for the mean.
I thought I wrote it down.
Yeah. So basically, from that formula, we actually know the sum of the 15 students, believe it or not. We know the sum of their scores for the 15 students. Because you can multiply 67 times 15. And that'll tell you what all those 15 students, if you add up all their scores, what it would be. And that's the key to doing this question. Is to do this is a hard question, actually. This is one of the harder ones. This is one of the harder ones. I've done it before many times. That's the only reason I know how to do it so easily, is because I've already done this question like 100 times. But the first time I tried it, I was like, I didn't know how to do it. But
Okay.
it's all memorization is how you get good at something. So like, all you got to do is multiply. Do you understand that the sum of the 15, so the sum of the 15 student scores is 15 times 67.
Okay. 15 times 67.
Yeah. If you look at the formula, it's, yeah, the sum divided by 15 equals 67. So if you multiply both sides by 15, you get 15 times 67.
So, okay. So,
What's that equal to? 15 times 67.
1005.
So the way that you could write it down if you wanted to, you could put sum divided by 15 equals 67. Kind of like we did on the last question with the median question. If you have paper, you should write it down.
Oh, okay. So the sum divided by 15
Equals 67.
is 67.
And then below that, you write down, you multiply both sides by 15. Are you writing this down?
Yes.
So then you multiply both sides by 15. The 15s cancel. So then you have sum equals 67 times 15. Which is what? You said it, like 1,000 and something, right?
Oh, 1005. Uh-huh.
Okay, that's the first step of the question.
Okay, so it's going to be 1005. Okay.
You ready for the second phase of the question?
Yes.
Okay, the second phase of the question is to go to the next sentence. Let's see. Danielle is 65.4 inches tall. What is the mean of the 16 students? So add that sum plus Danielle's height and then divide by 16.
And that's it?
Yeah. Because then you have the sum of the 15 students, right? You have all of their heights. So you add Danielle's height, now you have the sum of all of the 16 students.
And that's going to give me the mean?
The mean of the 16, yeah.
Okay, plus 65.4. So it's 1070.4.
Mm-hmm. And then divide by 16, because there's 16 of them now.
Divide this by 16. 66.9.
Okay, there you go. That's how you do it.
Nice. Of the students is the class.
What did you say the answer was? 66.9?
9.
Okay, you could try it. Seems like it's right.
Oh my God. I'm sorry, I'm just impressed.
Don't be impressed, because I've done these questions a million times.
I need
Be
to
impressed if I figured it out if it was my first time looking at the question and I figured it out, then you should be impressed. But I've already seen this question.
Well, it's going to be, I need to write it in sum divided by
15.
what would you put, like, if I had a different question, what would you do? What's the formula, like the actual formula without saying like
The
15?
formula for the mean is the sum divided by n equals mean. I mean, we know that formula, right? The sum of x divided by n equals to x bar or mu. We're just applying that formula for the mean.
I mean, it sounds simple after you explain it.
I mean, yeah, once you know once you know how to do it, it is pretty easy. But it is hard. It's a hard question.
Okay, so for some reason, this is where I stopped last time, and I was very confused after. What is the mean and median of the sample of size 5?
Okay, so how did you do it?
I added, no, it was,
For the mean, how did you get the mean? Did you add them and then divide by 5?
but this one has a, which one's the mean again? Medium is the middle.
Yeah.
Mean is add all the values of the variable in the data set and divide by the number of observations.
Correct. Are you allowed to, are you on the test, are you allowed to use a calculator or StatCrunch?
Either one.
Either one?
Yes.
Okay. Which one do you like to use?
I have my calculator.
Okay. For this one, I would prefer StatCrunch because you can just click that box and you don't have to enter the data. So for this one, just hit the box. See it next where it says full data set. Watch, hit that. Open in StatCrunch. So it saves time because you don't have to enter the data into your calculator. All right, cool. So this is StatCrunch. I'm going to show you that StatCrunch is way better than a calculator. I could show you how to do it on the calculator if you want to, because you're the one that's taking the test. But real quick, go to Stat.
Okay, which is this one, right?
Yeah. Now go to Stat on the top. In fact, here, let me do it for you. If you want, I could do it for you. So watch, I'm going to go to Stat. I'm going to go to Columns.
Okay, so we're doing stat column.
And then I'm just going to click that, Shift. I'm going to click all 3 of these.
Okay.
And then I'm just going to press Compute. Really, all I need is the mean and the median. So mean and median. Wait, did it give both or no? I'm going to hold down Shift and then press me. Oh, let me hold down Control. Okay, look.
It's not.
I don't know how to get, whatever. I'm just going to get them all. So I have the mean and the median, see, for all 3 sets. I have for the sample of size 5, sample of size 12, sample of size 30. I don't have to plug any data into my calculators. See that?
Yes.
I don't need to do anything. Plugging data into a calculator takes too much time.
This is just make it sound so simple.
All right, now I'm going to do it again. I go to Stat.
Okay. Calculator.
Summary Stats.
Oh, summary.
And then Columns.
And then column.
And now I have 3 things that I can choose from. I can choose one of them or I can choose all of them. We need all of them, don't we?
Yes.
So if I hold down Shift and then press Enter on the 3rd one, then it selects all 3.
Okay.
Otherwise, if I don't do that, I can just do one at a time. I do this, I press Compute, and it gives me sample of size 5, and now I have the answer for the mean here and the median here, right? And then I close it, and I redo it, Stat, Summary Stats, so Stat, Summary Stats, oh man, Columns, and now I do 12, and then I just press Compute.
Okay.
But why not do them all at the same time, you know?
As well, yes.
Just select all 3 of them, go to median and mean. Is there any way to select both, just the median and the mean? Let me see if I can. If I press Control. No, how do I select it? Because when I collect, it's like I can't do both only. Like it doesn't let me select 2 unless I press Shift. If I press Shift, then it selects those. Press Compute. And it gives me the summary statistics for those 3 columns.
Okay.
So I don't know, do you want to try it now?
Yes.
I'll give up the control of your computer. Now go.
Okay, so stat.
I wasn't able to just pick mean and median. Maybe you can.
Ooh.
Oh, how'd you do that?
Command.
Oh, wow. My control wouldn't work when I tried it. Oh, because you have a Mac. Probably because you have a Mac. Yeah, and then just press compute. And now it only gives you the mean and the median for all three sets. See?
And what was my question again?
The question was asking for the mean and the median for those three data sets, I think.
104.3. What does that mean? 105.4. 102. This is so much easier. Oh, where did it go? What do you do with them?
Just click the box again, maybe. I don't know where it went.
Well, it gives me a chance to redo this.
Yeah. I'm not sure why it's disappearing when you leave it. Shouldn't do that.
And I already did the mean, so I just need the median, right?
Yeah.
Compute. So you're so right. This is much easier.
Yeah, it's pretty easy. StatCrunch is way better.
This is so much easier.
Of course, you don't have to plug the data in. You save so much time, right? StatCrunch, man, it's the way of the future. There you are. You're back on. This is cool.
Okay. What were we doing?
Guess you just had, what, one more for the size 30? That's it?
Yeah, 105. I think that was it, right? Okay, well done.
Cool.
Okay. Wait, what? For each task, now recalculate the means and median, assuming that the individual whose IQ is 108 is X and they recorded as 180. Okay. Then it's calculate the means and the median. Okay, so I need to change this to 180.
Yeah.
Okay. Let's see if I remember how to do this.
Yeah.
So, wait, stats. We need the 5, and I need the means, and six and 2.
It's probably still there, just behind that screen, I'm thinking.
6. You're amazing. Mean and the new sample the size. You've made this. Okay, wait. Let me find it.
Yeah, see how it's right behind her?
I want to do this one and do
Change
180.
180 for all three, probably.
So these are the three that I have left. Only the mean, right? It's asking for the mean only.
Yeah. Just move it to the, I don't don't know, to the right. Move it to the right a little bit so you can see the mean. Or the whole My Stat Lab.
I need to close this one.
No, like that whole thing. Just move it to the right. Other direction.
This way?
Yeah, a little bit more to the right, right, a little bit to the left. So that it still shows when you click the other screen. Yeah, like right there.
Okay, so for size sample 12, it's going to be 1, 3, sample 8. Right. You've made my life much easier.
Yeah.
I can't believe this. Again, what it was 102? Right?
Should be, yeah.
And I didn't do the median.
Wait. Click yeah. Click StatCrunch. Yeah, whatever. You can do it like that. You could also click StatCrunch
Right here?
and click Results. And then go to Summary 12, the second one.
Okay.
And now click Options. Edit. And then you can do it in there. That's just another way to do it.
Okay.
Show you different ways. Which ones does it want? Does it want
I was asking for the median.
for all three or just the top one? Or probably all three, right?
All three. I already got the first. Oh my God, what am I doing? Why am I not able to move this up? Oh, here we go.
Well, you only got the bottom two. You needed all three or no?
I already got the first one for sample 1.
So now click the other thing, the other page. And then just click that for 12, 106.5.
Has anybody told you how awesome you are? Thanks.
You're the first. No, I'm just kidding.
Let me tell you. Oh my God. Especially using Crunch, like I would never have understood that.
Yeah, StatCrunch is the bomb.
For each sample size, state what happens to the mean and state what happens for each sample size.
The mean increases, obviously.
And the median.
It might stay the same. I'm not sure. Probably stays the same. Yeah, third one.
The median.
Yeah.
I keep forgetting medium is the middle.
Yeah. The middle one should stay the same because if you're changing like the biggest value, then the middle.
And then
The middle value won't change.
Command rule that the number of observation place in
Resistance. I would assume that the larger the sample size, the more resistant it is. I would think that as the sample size increases, the impact of the misrecorded data on the mean decreases. I would assume A, but it might be C. It's definitely not B.
Okay, this question is asking me comment on the rule that the number of observation place
in resistance. So what resistance means, I assume they're talking about the resistance of the mean. So if there's a big value in a data set, then it's going to pull the mean towards it. Because 180 is like an unusually large value compared to all the other values, right? So what's happening is the mean is being being pulled towards. The mean is getting way bigger
Okay.
because of that one bigger value. The median is resistance, so it stays the same. The median stays the same. It's unaffected by that big 180 value.
Mm-hmm.
So
This increases the impact of the
now resistance.
remains. It increases. I mean, no. I mean, it decreases, right? It's been decreasing.
Yeah, decreases. Well, yeah, the impact decreases because if there's more data values, then that one big value is not going to affect it as much because there's so much data.
Yeah.
If the data set is small, then that one big value is going to affect it a lot. That's what I would guess, but yeah.
How could you be wrong, right?
I could be wrong. It could have been C, but
Remain the same. Okay.
cancel. So,
Here we see.
huh?
What does that really mean? What this is. Besides himself, he employs 9 other people. The salary by the employees are given below in thousands of dollars. Benjamin's salary is the largest, of course. Complete part 8 through D. Determine the mean, median, and mode of salary. Okay, so it's going to be the sum divided by all of them. Am I able to do that here also
Yeah,
on StatCrunch?
yeah. StatCrunch will give you the mean and the median. I don't think it'll give you the mode. It kind of can give you the mode.
Column. And wait, was it variable 1?
I'm not going to tell you.
Why is it only giving me variable 1?
I don't know. You tell me.
Is it because I only, what is going on? I've lost my rows.
Variable 1 is if you click on the rows and click to the left. Just click on a cell.
Where's my row 1, variable 1?
Click on the cell, and I'll go left arrow. Press the left arrow.
Okay. So it's only doing the first one, right? And I want all of them.
Now, variable 1 means the first column.
Okay.
So there's only one column, so there's only one variable,
Gotcha.
right?
Yes.
Yeah.
So I need the means and median. Compute. Oh.
There you go. You had to select it.
Ooh. I'm learning amazing things with you.
Yep.
This one here. I'm gonna move you up here. So determine the mean and the median. That's gonna be mean. 50. Okay. Now the mode. I think I have. I don't think I have that in my notes yet.
The mode is the value that occurs the most. The value that occurs the most.
Hold on. Let me write that down. Because I'll forget.
Hey, you want some chocolate?
Yes, please. I would love some.
Here, take some. Or do you want yogurt covered almonds?
That sounds delicious, actually.
That one? Okay. You want some of those? All right.
My nieces are here.
What's up, nieces and nephews? Huh.
Give me 1 sec. Got somebody that joined us.
Hey, little doggy dog, Snoop Dogg.
Okay. I'm still in my pajama bottom, so.
What?
Go. 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 Okay, you're gonna edit all of this, right?
Yeah.
Okay, because I'm still.
By the way, you could stop your video and then if you have to do something,
How do I pause?
just click the video, the camera. Like watch, it says stop video. See how you don't see me anymore?
Ooh. Where did you? Oh, no, wait.
Stop your video real quick.
That video. Okay. Okay, give me 1 second.
Sure.
I'm back.
Cool. All right.
Good. As a result, Jen has a total of $25,000 in bonus paid to distribute to his employees. One option for distribution bonus is to give each employee, including himself, $2,500, and the bonuses under this plan to the original salaries to create a new data set. Calculate the mean, median, and mode. How to.
It's a good question.
Okay.
Is it in thousands? It must be in thousands. So you basically, that's interesting. They're adding 2,500 to everybody, right? So you're adding basically 2.5.
Go potty. Sorry. Go potty. You need to go potty. Go potty. It's okay. Sorry, my brother's not home.
It's okay. I'm guessing. My guess is that we're going to add 2.5 to the answers from the previous answers for the mean and the median. But we should probably verify that.
To the okay, so 2.5 to the mean, medium, and mode. So we're adding 2.5 to every
Number? Yeah. Yeah. But I'm guessing, I think that the mean, median, and mode will be the same, but you just add 2.5. Try it. If not, then we can do it the hard way and calculate it.
Okay. So
But huh? I want to show you something interesting. I actually, for my own benefit, I want to see if I can add 2.5 to all of those numbers. And the way you do it, let me see if I know this. This is for my own sake. Can you go to data? Go to compute, expression. And in there, I want you to press build.
let me close them.
Yeah.
Don't go nowhere.
Okay.
Okay.
Okay, so try this for my own sake. Hit build and click variable 1. Double click. And then hit plus 2.5.
And I hit plus
2.5.
5.
Curious about this. Press OK. I want to see if this works.
Compute.
Okay, cool. It worked. So, right, it added 2.5 to everything in row 1. So we could find the mean and the median of those.
That is amazing.
Yeah.
Okay.
I kind of did that for myself because I'm trying to learn StatCrunch.
Oh,
Or just get back. I know StatCrunch pretty well, but I'm just double checking.
So if I click on options, am I able to go through this, or should I just go?
Maybe. I would just go to stat.
Save, copy, print?
Hit edit. See what happens. You can try it. Say to edit. But no, but it's still in that build mode. It's only in that. That's an expression.
Okay.
Because we never did stat. So you got to go to stat.
Stat, summary, column. And the median. Oh.
Does it have the mode there, by the way? I don't know.
Oh.
Oh, cool. It has a mode. That's nice.
Aren't you amazing?
Don't flatter me. Come on now. No, I'm just kidding.
So serious.
Keep it coming. Keep it coming. Keep on the flattery.
Wow. I should have taken your class.
I've never taught my class using StatCrunch.
No? Well,
Never. I always use the calculator, but I'm going to for the
Me-
first time. On Monday will be the first time I do it.
you're making my life much easier.
Yeah. I'm going to use StatCrunch for the first time on Monday.
Well, you're gonna definitely make all of us students much happier. I have like my scratch papers and
Yeah.
ready now.
Yeah.
For the new data set is 52.2. 52.5.
Was I right in my theory that we're just adding 2.5 to everything for the
Yeah.
mean and the median?
It just won't go away. How did the mean, median, and mode compare to the originals? Increase. I did not change. I did change. Everything changed, right? The median and mode did not change. Just increased by 10%.
It's D, right? That's what I originally thought.
Increased by 25. Yeah. Teacher, now this is so long. As a second option, Benjamin can give each employee a bonus of 5% of his or her salary.
I'm guessing that I like this question. It's kind of cool.
This is going now. It's giving us in percentage, right?
Yes, this is going to be fun. I want to add 5% to everybody's salary.
From the original.
Yeah. I'll show you a cool. I want to practice StatCrunch with you. So watch. Go to data.
Close this out, right?
Yeah, you could close that. Go to data, and go to compute, expression, and then go to build. And I want you to put variable 1. Press double click, and I want you to say times 1.05.
1.05.
That's how you add 5% to it. You multiply it by 1.05. That's a new thing I just taught you. I don't know if you knew that. But if you want to add 10%, you multiply by 1.1. If you want to add 20%, you multiply by 1.2. If you want to add 5%, you multiply 1.05.
Oh. Okay. Wow. Cute.
So it's probably going to, guess what? My prediction is that the mean, median, and mode are going to increase by 5%. That's my prediction.
Are going to increase?
Yeah, increase. Because we increased everybody's salary by 5%. So my prediction is that the mean, median, and mode are going to increase by 5%.
Okay.
That's my prediction. So if you want to, you can go to stat. No, you got to go to stat this time.
Oh. Oh, yes. Sorry.
Yeah.
This one, mean, medium, and mode.
10% of 550 is 5, so
5%.
5% is
52.
2.5, so 5250. Yeah, same thing. 5% is 2,500.
Yes.
So I was right in my prediction, apparently.
Are you teaching an online class?
I'm teaching an in-person class, but online. So everybody meets on Zoom like this.
Oh.
Yeah.
This is going to be 52.5. You are so amazing.
Keep it coming. Keep it. I'm loving it. I'm feeling so good. I'm like blowing up over here.
Oh my gosh. It's just, I kept reading this over and over and over, and now it's not. Fantastic. How do the mean, median, and mode compare to the original? The mean increased. The three measure increased by 5%. Wait,
Yep.
increased by 2,500, but the median and the mode did not. No, the mode did not. No, all three measures increased by 5%.
Yeah.
Correct?
Yeah.
You make me cry. With our option, he kept 25,000 for himself.
Oh.
Recalculate the mean, median, and mode. How do they compare to the original? So I'm going to add 25,000 to the last class.
I don't get it.
I don't understand either.
Benjamin decides not to give his employees a bonus at all. Instead, he keeps the 25,000 for himself. Use this plan to create a new data set.
And according to the original question of here, he's the one that makes the most.
Oh, yeah? Oh, so just add
25,000.
25 to 90, yeah.
Right.
The mode and the median will stay the same, but the mean will change.
The same as the original?
Correct. The mode and the median will stay the same.
Mode and median will stay the same.
Because the mode is the number that occurs the most, which is 50.
50.
So if I change the 90 to 115, that's not going to change anything. The median is the middle value, so if I change 90 to whatever, that's not going to change the median or the mode.
I can't remember what was it was 50. All of them, right? Yeah.
Yeah.
So what's the mean? It's 50. No.
Oh, no, the mean is the only one that changes. The
Okay.
mean is the one that changes because the mean incorporates every value, right? So for the mean, you have to add 25.
It's going to be,
For that, you have to calculate it.
so I use
If I was you, I would just go to variable 1
to this one.
and then add 25 to 90. So 115.
115, you said?
Yeah,
Okay. Because I'm adding 25 to 90.
yeah,
Now I'm just going to compute this one.
yeah.
That's summary.
But it's good that you realize that the mean is the only thing that's going to increase. The mode and the median will stay the same.
So I shouldn't even bother like doing.
No, you should just to kind of verify it, but it's good that you know that.
So the mean changed to 52.5.
Yeah.
They changed by 2, like 5. And then the median. So the mean is 52.5. Okay. The median is still 50. And the mode seller is still 50. Do the mean, median, and the mode compared to the original. All 3 meters. The mean 2.5 for the median and the mode. It's gonna be B.
Man, this homework takes a long time to do, but it's good. It's very time consuming.
You're welcome to like quit anytime you wish.
No, it's good. I'm just saying, for like students having to do this would take. If you didn't know if you weren't that good, like, man, this would take forever.
Imagine what I've been struggling with.
Yeah.
And then I have my test tomorrow, so I'm like, I don't know what I'm gonna do.
Yeah.
I'm supposed to be up to like section 4.2, I believe.
The test covers what? 1 to 4?
1 through 4. That's awful, right? Are you doing a summer class?
Yeah, 6 weeks. Just drop your class and take mine.
Am I still able to?
Yeah. Oh, well, it's kind of full, but you can.
See, I think if we would have like at least the way you're doing it with Zoom, and we can ask questions, it will be easier. But doing it on our own, I'm lost.
Or 1 and 4 too.
The what?
No, I'm thinking about 4, 1, and 4 too. Wow, your test includes 4, 1, and 4 too.
Yes.
Yeah.
That's too much, right?
Yeah. Have you started that homework for 4, 1, and 4 too?
No.
Yeah, then you're gonna fail.
I'm trying to stay up all night.
The only way to pass a class is if 2 days before the test, 2 or 3 days before the test, you finished all of the homework, and at that point you just start reviewing. That's the only way to pass the class, period. If you're doing the homework the day before the test, you are definitely going to fail.
Don't tell me that.
I know, I'm sorry. I'm just trying to tell you this because I want to give you the information, because that's, if you know that, then you can pass any class easily. If you finish all of the homework 2 days or 3 days before the test and then you start reviewing, you will definitely get an A.
I did amazing the first week. I was up to date with my homework, with everything. Coming the second week, I just lost myself trying to figure out like what I was reading.
Yeah.
So that's why the second week has taken me forever.
Well, now you know. I just gave you information that will help you to get an A on any class. If you just do that, you will definitely get an A.
There's still a chance, right?
Yeah, you can pass. You can still pass the class easily. Just do that. What I said. Just make sure you are very diligent And just, like I said, 3 days before the test, all your homework needs to be done.
3 days before the test.
At least.
I can study.
As soon as possible. Your homework needs to be done as soon as possible.
Okay. Sorry, my nephew's walking around.
Make that your goal.
Definitely.
Yeah.
I just need to get through this week, and that way I can catch up with next week.
Yeah.
Okay. Let's see. Is the trimmed mean? It is computed by determining the mean of the data set after the mean, deleting the smallest and largest. Papi, go get a diaper. Go get a diaper.
Are you babysitting?
My mom is, but since they were watching a movie in my room, I came to my brother's room, so they're all like getting ready for bed.
Go get a diaper. Go get a diaper. So yeah, trimmed mean just means get rid of the biggest and smallest data value. That's what it says, right? Trimmed mean.
Get rid of the smallest.
Smallest and biggest data value.
You said the smallest and largest, right?
Yeah. Yeah.
Okay. The smallest, largest. Okay, the trim mean. Further than giving table was okay, so the mean is going to be 0. It's the trim to be resistant.
Huh. Now imagine you plugging this data into a calculator.
Yes, that's what I've been doing.
That's ridiculous. That's so. I just saved you like so much time by teaching you StatCrunch.
That's why it's been probably taking me forever to do the other stuff.
Yeah.
Okay, so for this one, I closed this one completely, correct?
Yeah, you could do that. Sure.
And then, wait, this is not giving me, oh, here it is.
I hope StatCrunch is available on the test. It should be, but
Hopefully.
yeah.
Okay, so wait, it's asking me to do what?
Find the trimmed mean.
So I need to just get rid of.
Well, it says is the trimmed mean resistant also. Yes, it is resistant. Hold on. But yeah, first find the trimmed mean.
Oh my goodness gracious.
Okay, so I'll teach you. I see your issue. You want to find the largest and smallest value, right? And you're seeing that's hard because the data needs to be in order, right? If it's in order, that'd be easy.
Yes.
So just put it in order. Where would you go to put it in order? Data. Sort. And that's it. Just click variable 1. Just press compute. Well, I guess you gotta select one. Just select column. Go to select column and click yeah. There you go. Now it's in order.
Okay, so
I guess just go to 0.78 and just press delete. Or just press just get rid of that value. And then do that same thing on the top.
this one.
Yeah.
Okay.
And that's it. And now find the mean. Find the trim's mean.
Would it give it to me in the same place?
Yeah, yeah. I'll just go to mean. Because we've already trimmed it, you know what I mean?
0.87.
0.874.
0.874. Yes.
Yeah.
0.5 thousandth. Yes. I'm taking your class.
Now it says, is the trimmed mean resistance?
What does it mean by resistance?
Resistant means that it's unaffected by outliers. I would, it's a tough one. I would probably say yes, because extreme values affect it. Hold on. This is tough.
Is this the same one you're teaching, right?
Yeah. But the trimmed mean, that's a hard one to answer, because there could be multiple outliers, like big outliers. There could be 2 or 3. So if you cut one of them off, there could still be outliers. So it could be, wait, is a trimmed mean resistant? Resistant to outliers, it means. Like, is it affected by outliers is the question. It's asking, is the trimmed mean affected by outliers? But my thing is, what if there's 2 outliers on the top? So then I would say it's not resistant. No, because it's still affected, because extreme values do affect it still. But I don't know, it could be no, because you're cutting it off, because you're trimming it off, you know what I mean?
Yeah.
So there's like this big outlier and you're removing it. So then now it's resistant, because outliers don't affect it. But what if there was 2 of them and you just took off one outlier, but there's a second outlier? So I don't think this is a good question. So I mean,
This case,
let's see the possible answers. What are they? What are the bottom 2? What are the bottom 2?
no. Okay, so C is yes, because extreme values affect it substantially. No, because extreme values affect it substantially.
No, because extreme values affect it substantially. So it's either D. It can't be C, because resistant means that extreme values affect it, right?
Mm-hmm.
So the question is it resistant? So it's either no, because extreme values still affect it, or it's yes, or it's let me see, what else? It's either D or what? What could it be? Affected substantially, no. Do not affect it. Yes, it's either A or D. Yes, because extreme values do not affect it. I would say it's either A or D. Wait, let me think. No, because extreme values affect it substantially. That doesn't seem right. Go with A.
Oh,
Yeah, go with A.
all right.
I think it's a bad question, but still.
So extreme values do not affect.
Because we removed it. We removed the extreme value. But my criticism with this question, what if there was 2 outliers?
Mm-hmm.
And we removed one of them, but there was still another? Then it's still affected by outliers. So this question's actually a bad question. This would never be on a test.
God, I hope
Because,
not.
because it doesn't make any sense. It's wrong. It's actually the question makes no sense. Because what if there was 2 outliers? two extreme big outliers and we removed one. Well, what about the other?
No.
So that's why this question is no good.
But you still got it right.
Yeah, because I kind of guessed.
Okay, so why is the median resistant, but the mean is not?
The median is resistant because it does not include outliers.
Well,
So the median does not include outliers. It's just the center value. But the mean does include all values. The mean includes all values.
include all values. I have to take notes. Sorry.
Yeah.
The median. It's not resistant. Wait, so the medium
The median is resistant.
resistant.
You could also write that down. The median is resistant and the mean is not. But you could also say the median is resistant to outliers.
Two outliers. And the mean is not.
Yeah.
Okay. So we are, the mean is not resistant because both sides.
So it's either B or C or A, because A is saying that the median is resistant while the mean is not, because when there are extreme values in the tail, the value of the median changes. So it's not A because the median doesn't change. I thought it was A until I read the second half of the sentence.
The median never changes, correct?
Correct. The median never changes.
The mean is not resistant.
That's correct.
It is dependent upon the sample size.
That's wrong. Switch that. Go to D.
The mean is not resistant because when data are skewed, there are extreme values in the tail,
Keep going. This sounds good.
which do not pull the mean in that direction.
No, it does pull the mean in that direction. So that's false. It has to be B.
Okay. The mean is not resistant because when data are skewed, there are extreme values in the tail, which tend to pull the mean in the direction to the tail. The median is resistant because the mean of the variable is the value that lies in the middle of, yes.
B.
Yes.
Yep.
It's doing 20. You're fantastic.
I like to think of the mean as a cat, which chases its tail. So if it's skewed left, then the mean goes to the left. Think of like a cat that's chasing its tail.
Mhm.
So the mean is a cat. The cat is mean and it chases its tail.
Okay, I like that. That actually, yeah.
Yeah. So if it's skewed left, then the mean is smaller than the median because the mean chases the tail. If
Okay.
it's skewed right, then the mean is larger than the median because the mean is bigger. It goes towards the skewed to the right.
I like that.
Yeah.
How'd you come up with that?
I don't know. I came up with that many years ago.
That makes it more
Yeah, it's like a good analogy, right?
yes. Okay, we're almost there.
We're almost there.
In 1994, Major League Baseball players went on strike. At the time, the average salary was $1 million.
I know this question. Basically, this is the thing. The average salary is bigger.
The average salary is bigger.
Yeah. And the median is smaller, so it's skewed right. So like the players are gonna the players when they're negotiating, they're gonna mention the median because it's smaller. And then the owners are gonna mention the mean because it's bigger. It's $1 million.
So what's the question? Which summary would you use to convince the public the strike was not needed?
Yeah, if you were representing the owners, you see that? If you were representing the owners, you would use the median because it's smaller.
Because, oh, I see. Okay. If you were
If you were a player, you would use no, hold on. If you were the owners, you would use the average because it's bigger. So you're like, hey, I'm already paying you a lot.
all this money, but if you're
But if you're a player, you're like, hey, our salaries are small.
yes, the convenience. The public that strike was needed. The average and median salaries different. So it's really because the mean.
It's skewed right. It has to be skewed right because the mean is bigger.
So so the mean is bigger, the median
Yeah.
skewed.
The mean chases the tail. The mean chases the tail. So if the mean is smaller, then it's skewed left. If the mean is bigger, then it's skewed right.
Yes. Say that one more time. The mean.
So the mean chases the tail. So if the mean is bigger, then it's skewed right. If the mean is smaller, then it's skewed left.
The cat chases the tail.
Yep.
Nice work. This one question again. Okay.
Uh-oh.
This is like the final one.
Dun, dun, dun.
No. For the distribution shown, which letter represents the mode?
The mode is A because it's at the peak. It's the number that is repeated the most.
The mode is the value that occurs the most. Okay.
Yeah. The value that occurs the most would be at the peak of the curve, the very top of the curve.
The most occurrent.
Yeah.
Oh.
Wait.
Okay. You're fantastic.
Yay.
You make this sound so simple.
Because it is.
It's not. What happened?
Go to next. Wait, hold on. Oh, I guess that's it?
This is it for this chapter, yes.
Oh, okay. Do you have 3, 4, and 3, 5, or is this it for chapter 3?
Well, I have all of them. I still have to do all of them. I don't want to keep you all night either. Am I supposed to leave?
Huh?
Am I supposed to, wait, what's it asking me to leave?
All parts are showing, so I guess you're done.
So, yeah, so I'll save. Okay. You're fantastic, you know that?
There you go. Keep it coming. Keep it coming. Say more of that.
You're amazing.
I'm going to just call you whenever I want to feel good about myself.
Please do. Because I have many things to say great about you. It doesn't.
You have 5 attempts.
Yes.
What the dang?
I hope you have the same thing for your students, right?
1.
Why?
I don't know.
Because they have you, and we don't have a professor like, you know. Does it make sense?
My students take it live. It's like a regular test. We take it all together. We don't do it whenever we want. Everybody takes it at a certain time. Our class is scheduled. This class is flexible. You have an online class. My class is not an online class.
It's more like, it will be like a normal class.
Yeah.
Oh, wow.
Do you want to do another section or what?
Would you mind?
Go for it.
3.2. Wait, what was I supposed to do? So we did 3.1.
Go to the very top. Now on day 1, click that arrow. Go higher.
This
Click
one?
that arrow. Now go to day 2, click that arrow. Go to day 3, click that arrow. Go to day 4, click that arrow.
You're like, I'm over, over it.
All right, cool. Is this where we are? I'm teaching you. I didn't know if you knew that you can do that. Could that make it quicker?
I would never have thought about, making it small. I don't know. This is
Yeah, so that makes so you can like navigate quicker.
And honestly, this is the first time I've taken an online class.
Yeah.
As you can tell. Okay, 3.2. Ready?
Yeah. Let's do it. You want some more chocolate?
Oh, please, because this is like, this has me like super tensed up.
Right.
Okay, true or false? What? How do you say the name?
Huh?
How do you say the name?
Chebyshev or Chebyshevs.
Yeah. Inequality applies to all distributions regardless of shape. But
That's true.
Okay. So this is true. It applies to all distributions regardless of all shapes.
Chebyshev's inequality applies to all distributions. Empirical rule applies to bell-shaped. Only bell-shaped curves, okay?
I need to write this down. Bell shapes. And
I think that's true. I don't really teach Chebyshevs. I kind of skip it. But I do the empirical rule.
you should have taken your class.
I don't even know Chebyshev's inequality, but we can look it up.
You want me to look it up?
Not right now. Just click true.
True. Wait. There's only one true.
Yeah, just click true.
This book is so tricky. You can find the sample variance and standard deviation.
This is easy. The StatCrunch gives it to you.
Choose the correct answer below. Fill out in the answer box to complete your.
Notice that it says sample variance and standard deviation. Sample, the word sample. There's population and then there's sample. A population is everybody, and a sample is a subset. So yeah, so click the box. I'll show you how to get it.
This one, right?
Yeah.
How long have you been using StatCrunch?
I've never taught I taught a class with it like 5 years ago. I taught a class with it.
Okay.
Once.
So
One time.
only once?
Yeah.
I'm like an expert. Okay, so I have my sample.
So how do you find it? Go do it. Same thing we always do.
And I want to find, what am I trying to find?
The variance and standard deviation, but the sample variance and sample standard deviation. So just click variance and standard deviation for now. And then I want you to click the standard deviation too. And I also want you to scroll down more. Now look, it says unadjusted. That means population variance and population standard deviation.
Mm-hmm.
Unadjusted. So keep that in mind, that there's two. There's regular one, and then there's unadjusted. Keep that in mind for later.
Okay. So I want to ask what's the difference right now?
Hey, don't eat so many of these, man. I want some too. Quit eating them all. All right, go. Yeah.
Do I want to ask what the difference unadjusted and
One of them is a sample, and the other one is for the population.
So I'm assuming unadjusted will be the population?
Yeah.
Okay, and the variance is the sample.
Yeah.
Okay, so how did I?
Now,
Let me put my little. You can see it on the side. Okay.
notice that it says S squared and sigma squared.
Yeah, I was gonna ask, what's the deal with that?
So S squared stands for the sample, and then sigma squared stands for the population. Both of those are the variance. S squared stands for the sample variance, and sigma squared stands for the population variance.
Is it respect letters to represent this? No, this is something.
Greek letters represent the population.
Okay, so it is the population.
Greek letters, so sigma.
And then would it be considered?
S, English letters are for the sample.
Yes, represents statistics, which
Statistics, yeah. English letters are for statistics, and Greek letters are for parameters for the population.
okay. Okay. So standard. Okay, I'm lost. I'm sorry.
So now let's see. We want the variance, so just grab the variance.
This is asking
Now
for-
it said sample, so it's 53.3. We'll put it in S squared.
and the standard.
So that would be called the sample variance. That is the sample variance because it's S.
Okay.
So we're done. We're done for this one. It's either A or B. You just pick one.
Oh, okay, okay. Okay, I think I get it now. Thank you.
Yeah, so sample variance.
The sample variance is it's asking for the Roman letter, which is the S, or English letter.
Mm-hmm.
Okay.
Now it's asking for the standard deviation. Now, since the question said sample, we have to use S,
S.
and the answer would be 7.3.
Unless I see up here population.
Population.
Okay. So 7.3.
Yeah.
One decimal. Okay. What are you drinking?
Oh, this is just, I can't say, but Coke maybe? Coca-Cola maybe? Maybe, I don't know.
I think I need a whole bottle of Coke.
You need some of this Coca-Cola too, right?
Okay, the following data represents the flight time in minutes of a random sample.
Notice that it says sample.
Sample, so we're gonna use the Roman letters.
Yeah. They call them Roman?
Well, in the book, when I was reading it, I was taking notes. It says the Greek letters represent, I don't know how
Population. Parameters.
parameters, and the Roman letters XS represent statistics.
Wow, they use Roman. That's interesting. Cool. I always call them English letters, but cool. All right, for this one, I just wanted to point out the word sample.
So okay, I need to be looking for those little words, right?
Yeah,
Okay.
and that's it. It's asking for the range. The range is the biggest minus the smallest.
The range is the biggest minus the smallest.
Yeah.
It is. And let's see. biggest, which is 284. And the smallest is 257. 27?
Yeah.
Now, if you were to use this on StatCrunch,
You could do it. Just click the box and then do range. That's it.
so
Go to stat, columns, range.
that
Summary stats, columns, variable 1, range.
just look for range.
Yeah.
Can I just draw hearts around you?
Keep it coming. Yeah, I'm feeling so good. You know, just keep that coming.
Yes. Okay, the sample standard deviation of flight time. Sample deviation, and I can still do this on this, right?
Yeah. Go to options
What do you mean options?
on that box.
So once I have this open, like this little box, I can do
If you want, you can edit it. You can go to edit. Yeah.
and then I can just look for standard deviation.
Yeah.
Oh my gosh. I think I want to cry. This has me. Hold on. I need to go get a bottle of Coke. I'm going to owe you a giant bottle of Coke. How many type or decimal round to 1 decimal, please?
1, yeah.
Have I mentioned how amazing you are?
Keep it coming. I'm feeling great.
I was tearing my hair out.
I made a video of this question, actually.
This one?
Yeah.
Will we look for it?
If you want. That's a horrible video. I made it's like my first video I ever made, but if you type in
And I want to see it.
some summary statistics with histogram or something.
Summary?
Match summary statistics with histogram.
Let's see if it comes up.
There it is.
Which one? This one?
That's my video.
Video math. Yes.
I made that video a long time ago. First video ever made.
Summary statistics with the histogram.
I hate this video
Summary statistics.
because it's the first video I did. I didn't know what I was doing.
One observation that we can make here is that the mean and the medians are
Look at how many views it has.
both either 59
That's really
or both
good.
69. And the second summary statistics has mean and median 69, and the other ones are all 59. So we have to find that. That's like our first thing we should look at. So if we look at the first part, let's look at graph A. So graph A seems to be centered around 59, so that's not going to be the second summary statistics. Let's look at B. B seems to be centered around here. It's sort of the middle of everything, and that's 69. Okay, so that's it. That's going to be summary statistics 2. So we can put a 2 here. We're done with that one. Let's cross it out. All right, now we have to do the other 3. Now, one important thing to note is that the standard deviation on 1 is 1.5 and 4 is 23. See these 2 standard deviations? So we want to see, we're gonna sort of hone in on that. So if we look at graph C, notice that it's going all the way from 119 to like -1. So that's a huge range, right? The range is about 120, right? Now, what about this range? What's this one? This range looks like it's 54 to 64. Oh, that's it. It's 10. That's pretty small. Okay, let's look at this one. It's going from like 29 to 89. What's that? 60. So that range is 60. Okay, so all right, so that tells us a lot. So graphs C and D are the ones we're looking for. So C is the biggest range, so that's going to be 4. Summary statistics 4. And D would have to be summary statistic 1. Leaving A, the last one, that's going to be 3.
Okay.
See if you can do it now.
How do we stop this?
I have no idea. Just press pause. Can you do it now or no?
Okay, so I need a stretch. Okay, so, the medium.
Do you remember the first thing I did?
You were looking for the medium, right?
Yeah. But do you recognize between 1, 2, 3, and 4 which one is different?
2.
That's right. So one of them is larger than all 3. One stands out. Like the middle of all 3 of these, which one has the bigger middle? So what's the middle of D? It's either 51 or 59. Does that one look like 51 or 59?
With the D?
Yeah. Does it look closer to 51 or to 59? The middle.
51.
Okay, so good. So then that's not it. What about C? What does that center look like? 51 or 59?
Will be 59.
That's it. So then that has to be 2.
Wait.
So C has to be 2
Because
it has the bigger center.
I'm looking at.
So that one has a center around 51. Part D. Part C has a center of 59. And parts A and B have to have a center of 51.
Oh, now I get it. Okay. Okay, so C is 2.
Yeah.
I get it. So the rest are 51, and the difference is the standard deviation.
So yeah. So what did I say? What was my point about the standard deviations? Do you remember?
Something about the range.
Right. And I was like, I looked at the standard deviations and I noticed that I looked at the smallest and biggest. So which ones are the smallest and biggest?
2.2, and the biggest will be 18.
So then now I look at the ranges for all of them and I find out which ones are the smallest and biggest. So what's the range on A?
That's probably 1, right?
Not the distance of that thing, but the biggest minus the smallest. Remember, the range is the biggest minus smallest.
So it's 46 minus 56. No.
Yeah.
Wait.
So what's the range? 10. So for A, it's 10. So then go down to B. What's the range on that one?
When you come across something like this, that this is empty, like the beginning, do you still?
I just ignore it.
So do you?
I mean, I guess I could take that second value, but I'm just rough estimate. It's like a rough estimate. So just 81 minus 21 is 60. If you wanted to take that second value, you could call it 26 maybe, and do 81 minus 26. It's a little harder to subtract.
It's not a, you don't.
I'm just getting a rough estimate right now.
Gotcha.
It's close enough to the thing, you know?
Yes, and then -9 is 111. So
That's 120 because it's 111 minus -9. So it's actually 111 plus 9. So that's like 120.
Okay.
The point is that in D, it's really, 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 really wide.
Okay.
The standard deviation would be the biggest. That's the point.
So, I get what you're saying now. So D will be 5 because that's the biggest, correct?
Yes. 4.
Yeah. Okay. Now we got C. B, we said it was like 60, and that will be 9, 3, 1. Am I right?
Yes. Yes, you are. I think you are right.
Can I just keep you?
I charge $60 an hour. No, I'm just kidding. Yeah, right. Charge like $150 an hour. I should. If I tutored, I'd probably charge like $150 an hour, $100 an hour. If I did, but I don't charge. So you're basically getting like $100 an hour worth of free tutoring.
I'm gonna buy you a bottle of Coke.
Yeah, Coke.
Red Coke.
A bottle of Coke would be like $1 million.
Okay.
On this one,
exam scores and fitness. Should have class out using the flipped classroom. Complete parts if C. Traditional and flipped.
it's asking for the range first.
So, the traditional course. I'm enjoying this.
When it's easier, right? Yeah, it's like, hey, this is easy.
Yes, column. It's gonna ask for, right?
Huh?
I think it's gonna ask for both eventually, right?
Probably.
And I'm looking for 3. Sorry, I'm just excited to see how it is. Why do I keep moving this? Okay.
It's crazy. There's always somebody out there that has the knowledge that you need in everything. In everything, right? Like you could be painting and like there's somebody out there that's like an expert painter, or you could be like making your own computer and there's someone out there who really knows how to make computers or something, you know? Or you could be like trying to learn how to play guitar. There's somebody out there that knows all the little tricks on how to like play guitar, you know?
You know how to play guitar?
I'm pretty good.
You know how to play the guitar?
Yeah, where's my guitar? It's in my car.
Oh. Well, maybe if you know, I would like to see you playing the guitar.
All right.
I took a class because I wanted to learn. And after that, I just took the guitar away. So.
You don't have a guitar anymore?
My brother has it.
Oh, okay.
It's somewhere.
Cool.
So the course has more dispersion. The traditional?
Yeah. Because the range is bigger.
You've made my life much easier.
I
Do you like cakes?
do, gluten-free only.
Okay. Wait, where the traditional, of course, the standard deviation. And set options, edit.
Yeah.
And I'm looking for standard deviation.
Yeah.
Oh my God, I want to cry how easy this is now.
Remember the days when you used the calculator?
I will have to do it by hand.
Dang.
That's why it's taking forever to do my work.
Wow.
How many decimals? Round to 3 decimals. Okay, 8.816.
Yeah.
The flip is 7.776, right?
Yeah.
And I can't believe I can do this.
You're a pro now.
Goodness. Score 59.9.
It's a good thing, you know, that we got connected because look at how much I helped you. Somebody was looking out for you.
What can I help you with? You want to learn how to knit, crochet? What would you like to learn?
Oh, that'd be so much fun.
You'll be surprised how much fun it is once you have something like finished.
That's true. That's true.
Like, no.
How does this affect the range? Well, obviously it's going to make the range bigger.
You just move 1 decimal point. So the range is.
If I was you, I would just like replace that number.
Do it, right? Until I feel comfortable.
Yeah.
59.5. So. And the traditional, it's only saying traditional, right?
Is it? Yeah, I think so.
In traditional, so. Three columns, traditional.
Mm-hmm.
Look at the range.
I'm gonna put this on YouTube and I'm gonna show my students. They're gonna be like, "Whoa!" They'll probably like love StatCrunch.
It is amazing. Just edit the embarrassing parts.
What parts you want me to edit? There's everything's been okay. I'll probably leave the whole thing.
Like my puppy, my nephew.
That's okay.
What?
Your puppy adds a lot of
Character?
value to the video. People that like dogs. No. Look at that puppy. What kind of dog is it?
He's a
Chihuahua?
apple chihuahua.
Huh?
He's an apple head chihuahua.
Hey, he's not. Is he like mad? Like if I came over, like would he like? Is he like do not like people?
Oh no, he loves people. He's an attention seeker.
But he doesn't like bark at you if like someone comes over? Because Chihuahuas, aren't they normally like super hyper?
They're very protective, I will call it.
Wow.
They're very protective. But he likes attention a lot. So if you start petting him, he will not leave your side. He will keep like scratching you until you continue petting him. Wait, what am I doing? So now I'm looking for the standard deviation. Options, edit. Ooh,
You're becoming a pro.
thanks to you. This
Yep.
is all Yeah. 3 decimal places as needed.
Now, I hope this is a sample. Is it a sample?
Yes.
Then that would be correct, as long as this is a sample. I never really I didn't carefully read the original question, but if I was doing it, I'd probably go read it. But
No, it is. It's just asking. This is suppose the score change.
yeah, but what was the original question?
Oh.
Not much, right? Go to the top part, click traditional on the top, and then scroll up.
Wait, you want me to do what?
The following data represents exam scores in a statistics class taught using traditional lecture, and it doesn't say if it's a sample or not. It could be the whole class.
I'm assuming it's a...
Is it asking for the standard deviation?
Yes, it is.
Then this might be wrong, because if that's now look, the population standard deviation and the sample standard deviation are going to be different. So, but who cares? We get 2 chances, so just put this as the answer, but realize that we are entering the sample standard deviation right now. Okay, just realize that. You need to understand what you are doing. You're entering the sample standard deviation, as if that was a sample of the class and not the whole class.
And then if I want to check population, it will be the
unadjusted.
Unadjusted. Okay.
Yeah.
0.6, like that?
Yeah.
Well done.
It was a sample then. Although the question doesn't say it, but it is a sample.
Are they considered a sample because they're talking about 2 different classes? So they're 2 different samples of...
Maybe because it's such a small data set. It's a bad question. It's not a good question.
The whole book is a bad question. The property does... What property does this illustrate?
Scroll up a little bit.
More?
Go up a little bit more. What did we do again? Okay, so we replaced 59.5 with 595. And what did it do? Now go down. What happens?
You changed it to the range.
The range should change, and also the standard deviation. Okay, good. What happened? Notice that the standard deviation went before. What was the standard deviation?
The range was 29 for the traditionals.
Notice that the traditional standard deviation was 8.8.
You jumped to something.
Went to 140, 145. Mm-hmm. We changed one number, and it changed it changed drastically.
Yes. Completely.
That's because it's not resistant.
Because
it's not resistant to outliers. Outliers affect it. It's not resistant to outliers. So watch, scroll down.
Both the range and the standard deviation. That's not true. The range is resistant.
Neither of them are resistant. D.
The range nor the standard deviation is resistant. Because they changed. Nice work.
Now this is the question about the empirical rule. That I know. Chebyshev's theorem I'm not too good at, but this I know very well.
Okay, this is the one that you said, okay, which is the bell-shaped.
Correct. This only works for bell-shaped distributions. And we have bell-shaped distributions here because it says it.
Mm-hmm.
So then it says 99.7% of organs will be between what weights? So the empirical rule is 1, 2, and 3. Just remember that 1, 2, 3.
Okay, 1, 2, and 3.
So within 1 standard deviation, within 2 standard deviations, or within 3 standard deviations. So you add and subtract 1 standard deviations from the mean. The mean is the center. Remember that. The mean is the center. And you're adding and subtracting 1 standard deviation for 68% of the data. And you're adding and subtracting 2 standard deviations for 95% of the data. And then you're adding and subtracting 3 standard deviations for 99.7% of the data. So it's also called the 68, 95, 99.7 rule. The empirical rule is also called the 68, 95, 99.7 rule.
Okay.
So if you Google, if you go to another tab and just put empirical rule, it'll give you a good picture. If you want to take a picture, it will show you a nice picture. Empirical rule.
Did you make a video of that too?
I don't probably, but there's so many pictures of this. If you just Google it, it'll show you a nice visual. Look at that picture. See that picture?
This
You
one?
see? Yeah, it's right there. Like click that. See how it says the 68, 95, 99.7 rule?
Mm-hmm.
Now click that picture. I don't know if you can click it to make it bigger. And then click like any one, like that one, for instance. That's okay.
No.
That one's okay. Look, it says 60. Look at those 3 sentences. 68% of the data falls within 1 standard deviation of the mean. 95% of the data falls within 2 standard deviations of the mean. 99.7% of the data falls within 3 standard deviations of the mean.
Mm-hmm.
And if you scroll down, it shows you a picture. And it shows you, see how you go to the right 1 and to the left -1? And there's 34 and 34. So 34 plus 34 is 68%. I don't like this picture, but if you go out 2 standard deviations, then and you add all those numbers, it'll add to 95.
And then once I go
If you go out 3 times, it'll add to 99.7.
7.
Yeah.
Oh.
So 68, then 95, then 99.7.
And that's for pretty much all, right?
Only for, yeah, whenever it says like, if it's roughly bell-shaped, then you can use this idea called the empirical rule to help you solve questions now. So like, for example, that example says,
Which one are you doing?
the lifespan of lizards is in a particular zoo is normally distributed. The average lizard lives 3.1 years. The standard deviation is 0.6. So estimate the probability of a lizard living between 2.5 and 4.3 years. So 3.1, if I add 0.6, I get 3.7. If I add, so this one's actually tough. Skip this one, bad example. It's a little bit harder for my taste that I would ever teach somebody, so skip that one. Yeah, close that.
Okay, so I should attempt this one.
Yeah, so this is probably easier. Like part A, it says 99.7. So all you got to do is add 3 standard deviations and then subtract 3 standard deviations from the mean. The mean is 310. So the mean is 310, right?
Okay, so I have 310.
And the standard deviation is 50, right? So if I add 50 times 3, which is 150,
Okay.
why am I adding 3? Because remember I told you 1, 2, 3?
Okay.
99, remember what's the name of the rule? 68, 95, 99.7? Remember that name? 68, 95, 99.7? So 99.7 is the biggest one, so that's the 3. So I have to add 3 standard deviations and subtract 3 standard deviations. This is kind of tough. Some people really struggle with this. Is that hard? So just check this out. Watch, I'm going to do it for you. Just kind of like observe. So what I'm going to do is I'm going to take 310. That's the middle.
Okay.
So I see 99.7. So I tell myself, oh, 99.7 is the biggest one. That's the 3. So I say, okay, since that's the biggest one, that's the biggest percentage. So that must be the biggest number, 3. So I'm going to add 3 times 50, because that's the standard deviation is 50. So 3 times 50 is 150. So then I add 150 to 310, which is 450 or 460. So then now I know that the upper limit is 460. And I also subtract 150 from 310, which is 210, 200, 160. So 160 to 460, or whatever I said.
160 to 460.
So yeah, 160 to 460.
And then 310 is the mean.
Correct. And notice how 310 is in the middle, and I add 150 to 310, and I subtract 150 from 310.
Okay. So A, about 99.7% of organs will be between what weight?
160 to 460.
Because 99, okay. 160 to 460.
Because the 99.7 is the 3, so I add 3 standard deviations out. I have to go out 3 times.
Okay.
If it was 68, then I would only go out once. If it was 95, I would go out twice. Since it's 99.7, I go out 3 times.
I don't understand this.
What part? Is it the terms that I'm using? What words that I say don't make sense?
Okay, so we have the weight of an organ. So if I'm reading this, 310 grams and a standard deviation of 50 grams. So it's 50 my standard deviation. Okay. Use the empirical rule to determine the following. About 99.7% of organs will be between what weights?
I'll explain it to you in a more intuitive way. The empirical rule tells us, let me think. It's hard to explain. Okay, let's think about this. Think about incomes. Let's say people make on average 100,000. Well, if incomes are normally distributed, then we could say 68% of people make between 80 and 120 if the standard deviation was 20. I'll say that again. If incomes were normally distributed and people made on average 100,000, then we would say, let's say the standard deviation was 20,000. So they make $100,000. Let's say Americans make $100,000 with the standard deviation of 20,000. If incomes were normally distributed, we would say that 68% of people make between 80 and 120,000 by the empirical rule. Do you see how I'm getting 80 and 120?
Yes, because that's 1. You started at 1, correct?
Correct. 1 standard deviation, and I said that the standard deviation was 20,000.
Mm-hmm.
So it kind of gives me a rough estimate of how many people make between $80,000 and $120,000. So I say, okay, 68% of people make between 80 and 120,000, right?
Mm-hmm.
By the empirical rule, because incomes are like everybody's sort of concentrated towards the center because it's normally distributed.
Okay.
So most people make like near 100,000.
Yeah.
But less people, as you go out from the center, less people make that money, right?
Yes.
So like what percentage of people make between, here's my question, between 60 and 140,000?
That will be the 99.7.
No, 95.
95?
Because 60 and 140, right?
60.
Do you see how I'm getting 60 and 140? Remember, the mean was 100 and the standard deviation is 20.
Okay, so the mean is, you said what?
100.
100.
And the standard deviation is 20.
Okay.
So do you see what's happening on that?
Somewhat.
The mean is 100 and the standard deviation is 20.
Mm-hmm.
So how am I getting 60 and 140? Write this down too. 100 minus 2 times 20. Write that down.
20.
And then 100 plus 2 times 20. What does that give you?
So this is how we get, oh, that makes sense. Sorry, I'm visual, I have to see.
Yeah.
Okay. Let me move to my room because the kids are ready to go to their bed.
Okay.
1 second. How did you say? Hold on. Is it going to bed? So. Okay, so I used the 100 minus 2 times 20. That should give me, I'm looking into what range there. Oh, yeah, 60. That's where you got 60. Okay. And 140. Okay.
So then what percentage of students get between 60 and 140?
And 140, it's going to be 95.
That's right. 95.
And we have the 99.7 here. This is the 68, 60. Oh, that makes sense. Okay, I think I make sense now.
Did you lose the homework question? I don't see it anymore.
It's right here. Can you? It says you're sharing the screen. You
I
didn't
see
see it?
something that just says Zoom. I just see the page that says Zoom.
No, I don't even. Let me see. Stop sharing and then I'll share again.
Yeah, that's a good idea.
See it now?
Nope. I only see Zoom. You have to share the desktop. Did you share the desktop or?
Let me see.
Maybe. Now I see it. Wait. Yeah. There it is. Maybe I was blocking something. I don't know. But yeah, well, it works now, so.
Okay.
What percentage of organs weigh between 210 or between 210 and 410?
This is the 99.7. Wait.
Was it?
Yeah. Yes.
No, because
Wait. I'm confused.
no, that would be 95. Because if you subtract 100 from 310, you get 210. You see that or no?
Yes. Why was I confused? Okay, because it says about 99.7. So I was thinking organs will be between 160. Oh, okay. What percentage of organs? Okay. I was thinking about question 1 or A. So this is 95. This is 95%.
Oh.
And then C, the integer organ less.
5%. That will be 5% because it's the opposite of 95. Because it says less than 210 or more than 410. Now think of that normal curve, that bell-shaped curve. In the inside, 95%. So if on the inside is 95, then on the outside has to be 5. Because 5 plus 95 is 100. So the answer to C would be 5. Does that make sense? Because you just subtract from 100.
Okay.
Notice that it says less than 210 or more than 410. Did you see that?
Yeah.
So it's a tricky one.
That would throw me off.
Yeah. It's a harder question.
Between 160.
And this is probably a tricky one.
Shouldn't be.
For this one, you'd have to draw it because.
See what I see. Okay, so
You kind of have to draw this one because 410 is the 95er. So there's 2.5% on the right. And then 160, there's only, what's 99.7 minus 100? 0.03. So the answer to this one would be 2.5 or 2.8, basically. But the reason it is 2.8 is because if you draw a circle, if you draw the like normal curve, this is just outrageous that they shouldn't ask this type of question, but it says between 160 and 410. So remember, 410 was the upper limit for the 99.7.
You said 110 was the upper limit?
No, 410, right? Remember in part B?
Yes.
Actually, what was that? Well, that was the upper limit for the 95%, right? In part B? So think about that for a second. 410 and 210, they contain 95% of the data, right? Think about this for a second. That means 5% is in the tails. So that means 2.5% is on the right tail. So if you draw a normal curve and you put 410 on the right, then you can put to the right of 410, you could say 0.025 or actually just say 2.5% to the right of 410.
2.5%.
So there's 2.5% in the right tail. And now do the same thing with the 160. Now on 160, that was the answer from A, right?
Yes.
So that tells me that 99.5% is in the middle. So 3% would be in the left and right. Actually, 0.3%, right? Because 100 minus 99.7 is 0.3. If you type in a calculator 100 minus 99.7, you'll get 0.3. Now divide 0.3 by 2, you get 0.15. Right? You're frozen. You gotta let it go. Because you're frozen, you gotta let it go. Oh no, are you there? I lost her. But the answer is going to be, let's see, 2.5% on the left, 0.15% on the right. That's 2.65%. Answer 97.35% seems to be the answer. And I lost her. So like I was saying, to the right of 410 is 2.5%, and to the left of 160 would be 0.15%. So 2.5 plus 0.15 is 2.65. If you do 100 minus 2.65, you get 96.35. Or 97.35. Try that, 97.35. It's just, this question would be too hard. I don't think this would be on the test.
97.35?
Yeah. 2.5. I did that right.
You did. You're just a genius.
Keep it coming. Keep it coming. Keep it coming. No, I'm just kidding.
Oh, don't worry. There's like a few more questions left for you.
Okay.
At one point, the average price of regular and leaded gasoline.
Chebyshev's inequality. Great. I don't know this one that well. Let's see.
The standard deviation price per gallon is. To answer the following.
So let's see. Within 4 standard deviations of the mean. So you have to Google Chebyshev's inequality real quick. It'll tell you how to do it if you Google it. CHEB.
I'm going to move you to the side now.
CHEB.
B, CV,
Y. CHEBY. No, CHEBY. There you go.
Which one do you want me to open?
Either, anyone.
Then
That's a nice one. So 1 minus 1 over k squared, where k is the standard deviation. Okay, so then the answer for ours is going to be 4. It's 4 standard deviations, so 4 squared is 16. 1 minus 1 over 16. Huh?
how did you get that already?
It says k standard deviations. K is standard deviations, right? In the question that we did, it said 4 standard deviations. So just do 1 minus 1/16, which is 15/16. So that's the answer, 15 over 16. Just find the percentage for that. Hey Siri, what's 15 over 16?
15 over 16 is 0.9375.
0.94.
To 2 decimals.
Or put 94. Wait,
Point.
2 decimal places. Actually put 94. Hold on. It has to be 93.75 or something like that. Whatever 15 over 16 is.
It's 0.9375, but this is.
So put 93.75.
Yes.
It wants the percent, not the decimal. It's asking for a percent. You have to convert what your calculator gave you to a percentage, right?
Yes.
So 93.75. Dang, Chebyshev's inequality is easy. I should start teaching it. So easy.
Oh my gosh. I'm sorry. It's impressive.
Or at least part A is easy. I don't know about B and C. Let's see.
Okay. Very
Hey, I'm gonna start teaching this one.
very quickly. How did you manage to? Okay, I don't know exactly what.
I just plugged in 4 into the question because it said 4 standard deviations, right? In part A, the number is 4, right? So I just plugged in 4. That's it.
So you plugged in 4 into K?
Yeah.
Okay, and then that's okay.
So 1 minus 1 over 4 squared.
Okay.
4 squared is 16, so 1 over 16. So then 1 minus 1 over 16. That's it.
Square 16. Oh. Okay. At least 1% of gasoline. What percentage of gasoline station had prices within 2.5 standard deviations for the mean? And prices that are within 2.5. So I'm plugging in 2.5 for K.
Yeah.
I'm not as fast as you are, okay?
Well, yeah, this one's a decimal, so that would be hard. That'd be 5 halves, so it's 25. 4 over 25, so it's 21 over 25. Hey, Siri, what's 21 over 25?
21 over 25 is
I'd say
0.84.
84. I don't know. 84 is my guess, but I could be wrong. I did that in my head, so it's probably wrong.
That's right.
It is?
Yes.
No way. Wow, that's crazy.
Okay, I mean, this is just like, I can't. Wow. Okay, I need a bottle of Coke.
The gasoline prices that are within 2.5 standard deviations of the mean are,
What am I, wait, are we still on the same one?
I guess, is that part C or what are we on? Oh, we're going on part B?
On B, and it's asking for the second one. What are the questions for
So for this one, just add 2.5 standard deviations from the mean. So it's 8%. Go to the top. It says like 8 cents or something.
0.08.
So I need to multiply that times 2.5. So 16 plus 4 is 20. So I add 20 cents. That's 367 for the upper limit and 327 for the lower limit. So 327 to 360.
You're doing all of this in your head?
Yeah.
Oh my God.
327 to 367. I don't know. Because 2.5 times 8 cents is 20 cents, I think. So I add and subtract 20 cents. That's it. I think, because aren't we supposed to add 2.5 standard deviations? Add and subtract 2.5 standard deviations?
Yes.
So then just add and subtract 2.5 times 8 cents. So 0.08 times 2.5 seems to be 20 cents.
0.2?
Times 2.5. Yeah, 0.2, which is 20 cents. So
Okay.
0.2. So then I have to add and subtract 0.2 to 347. That's easy. It's
Oh, okay. So, am I doing the adding or subtracting first?
subtracting first. Subtract 0.2 from 3.47. It's 3.27. And then 3.67.
I can't with you.
This is a good. I'm gonna start teaching this. This is so easy.
This semester, or are you gonna wait for next semester?
I don't know. I might do it this semester if I remember.
What do you mean? I mean, you're doing this like nothing.
I mean, if I remember to add it, because I'll probably forget. But it's because I have to add it to the homework
Oh, okay.
because it's not in there right now. But I like it.
What is the minimum percentage of gasoline stations that had prices between 3.
Okay, so for this one, we have to find out how many standard deviations are we moving out? How many standard deviations have we gone out? What was the center again? 327 or 347?
It was 347.
So if you subtract 363 minus 347, what do you get? 57, 67.
Subtract 3.
16 cents. You get 16 cents. If you subtract 363 minus 347, you get 16 cents.
Okay.
So it's 2 standard deviations. So 2 squared is 4. 1 over 4, it's going to be 3/4. So the answer is 75%. No, but like, right? I mean, did you see that? Is that right? I did that in my head kind of quick. It might be wrong, but try it. 75. It's probably wrong. I did it kind of quick.
Everything. Okay, I'm buying you 2 bottles of Coke. Just because you're very impressive.
Okay, so like, you see what happened?
No.
What happened was
like doing this and whatnot.
no. Okay, I'll explain what I did. It was 2 standard deviations, right? I noticed that it was 2 standard deviations because in my mind I knew that 347 was the center. So and then 363 was the end. So then I just subtracted that and I got 16 cents.
Okay, so you got 16 cents.
And then I was like, wait a second, 8 cents is the standard deviation, so that's 2 standard deviations. 16 cents is 8 cents times 2.
Yes.
So K is 2.
Oh, and that's where you replace the K.
Yeah, because 2 squared is 4, 1 over 4. So 1 minus 1/4 is 3/4, which is 75%.
You must make your parents very proud. The what? Hold on. I hope you
My brain works really good when I'm teaching, but when I'm not teaching, it doesn't work good. Only when you're doing something that you're good at, that you like, then you kind of get in the zone, and then your brain starts to work really good. But then when you're doing something that you're not good at, your brain shuts down. You know what I mean? So there's like psychology. When you're doing something that you do a lot, then you just kind of like excel and you do well at it. But when you're doing something you don't do well at, you're just kind of like, your brain doesn't work good.
do you dance?
Huh?
Do you know how to dance?
I like to dance. I'm not good at it. Do you like to dance?
I'll teach you belly dance. How about that?
Yeah, that's cool. You're like, I'm gonna belly dance or what? You're gonna teach me how to belly dance, or you're gonna belly dance?
I'm gonna teach you.
Okay.
That way I can feel smart about something for once.
There you go. There you go.
Oh my God, hold on. I just can't, like, the way you, wow. Hold on.
What is this one about? Is it the Empirical Rule or is it Chebyshev? So let's see. I don't know. It's Chebyshev's because it doesn't mention anything about standard normal curve, right? It doesn't say anything like that.
No, it's not saying anything.
So it has to be Chebyshev's. And since it's 2 standard deviations, we know the answer is 75%. We don't need to do anything.
Since we know 2 standard deviations, oh.
Wait, remember, we did that last time. 2. 2 squared is 4, 1 over 4, 1 minus 1 over 4.
75.
Yeah. It's the same question.
I can't with you. I just can't. I can't.
And this one is 2.5, so that one was that one. What was that one again? 5, 4, so 25. 16 over 25. Remember we did this one too. We did this one before. Right?
Sure. Wait, what? Let me read it.
It's the 2.5 one. Remember, we did a 2.5 one before. Because that's 5 halves. 4, so 16 over 25. I did this one before.
Look at my notes.
9 over 25. I asked Siri for this one. I know we did this one just like... But like I'm telling you, all you got to do is plug in 2.5 into the formula. You understand?
Yes.
Because K is 2.5. So just plug into the formula.
So I'm plugging in 2.5 into the formula.
Yeah, so you can do 1 minus 1 divided by 2.5 squared.
So, yeah, we did this one.
Yeah, we did this one.
Okay. So we said that 2.5 squared. It's
9 over 25.
just one. I think I'm doing it right. Or 4. That's all right. $6.16.
Sounds right. But you're going to have to convert that to a percentage, not a decimal. Because it gives you a percentage symbol next to the box. That means you need to put in the number, not the decimal.
16.
Yeah, is it exactly 16%?
Yeah. It's yes.
Wouldn't it be 36?
I'm doing something wrong here. Okay. Let me put in
So type this in. 1 minus 1 divided 2.5 squared.
I get 0.84. I'm doing something wrong.
Exactly 84 or what?
Exactly 84.
That's what we got before. It has to be 84 then.
Yes. I don't remember 84.
No, it has to be 84. I thought we did 84 before. I thought.
Oh. Why do I doubt you? Why do I even doubt you, huh?
I have no idea. So then now 2.5, you have to multiply. Do you know how to do this one or no?
Deviation of the mean are between blank and blank. The commute times within 2.5 standard deviation. No. Oh, no.
So for this one, it's asking for the commute times. So you just multiply 2.5 times the standard deviation because it's within 2.5 standard deviations of the mean. So 8.1 is 1 standard deviation. So you just multiply 8.1 times 2.5. And that's what you add and subtract to the mean.
And the mean is going to be
28.3.
Okay, so that's my mean, and this is my standard deviation. This is 2.5. Okay. 28.3 minus let's say 20.25, 8.05.
Okay.
And then add 48.55. That sounds right?
Yeah. Type in integer or decimal. Hold on. I guess. It doesn't say what to round to?
Use ascending order.
Try 8 and 48? I don't know. Does it want? I don't know why it says type in integer or decimal. It doesn't say what to round to. That's confusing.
8 and 48? Or
I had
40, so if I round off, should I round off 48 or leave it as 48?
What was it? 48 point what?
0.55.
Then it'd be 49. That's if they want an integer, but I don't know why they're not telling us what to round to. It's confusing.
We have another chance to check. Okay, both of your answers are incorrect. Find the value.
It doesn't say what to round to, though. Maybe round to what it told you to round to before. So one decimal place, maybe? This is the annoying thing, because this question is wrong, because I don't like when questions are unclear on what you're supposed to do, but whatever. 8.1.
One decimal. So 48.6.
That sounds good.
Oh. Value. And K is the given number of.
What's it say the answers are?
No, it doesn't give me the answers yet.
Oh, it doesn't?
I have one more chance.
Now, tell me what you did. Did you do 28.3 minus 2.5 times 8.1?
I did, wait, 28.3 minus 20.25.
Wait, minus 2.5 times 8.1, right?
Say that one more time.
28.3 minus 2.5 times 8.1.
No.
What was 2.5 times 8.1 again?
2.5 times 8.1 is 20.25.
20.25?
Mm-hmm.
So then do 28.3 minus 20.25?
Yes, and that's 8.05.
Try 8.05, I guess. I don't know. I don't know why it doesn't tell us what to round to, so it's a stupid question. And then what's this? 48 point what?
48.55. That will be 28.3 plus 20.25.
Yeah, try that.
Okay.
All that because they didn't give us the correct directions.
What is the minimum percentage of commuters who have commute times between 4 minutes and 52.6 minutes?
All right, so what we want to do is we want to start at the center, which was what again? What was the mean? 28.3. And we want to, find out how many, basically we want to find out how many standard deviations away that is. We want to find K. All we got to do is find K. So what's the difference? 28.3 minus 4 is 24.3, right? 28.3 is the center.
Uh-huh.
And the smallest number is 4.
Okay.
So that difference is 24.3. If you subtract 28.3 minus 4, you get 24.3, right?
Mm-hmm.
Now divide that by 8.1, and that's your K.
24.3 minus...
No, divided by 8.1.
24.3 divided by 20 what?
Divided by 8.1.
8 point.
That's the standard deviation.
Oh, you're getting the... Oh, okay. 3.
Wow. So then the answer is 8/9, because 1 minus 1 over 9 is 8 over 9. Just plug into that k formula, 1 minus 1 over k squared, remember?
Yes.
So k is 3, so 3 squared is 9, so 1 minus 1 over 9 is 8 over 9.
You're too fast for me. Like your brain's too fast for me.
So
I get 0.888888.
then it says round to 1 decimal place, so 88.9.
0.09. I mean 0.9.
Yeah, 88.9.
88.
You said that the answer was 0.888888?
Yes.
So then 88.9.
0. Point.
No. This is a percentage. 88.9.
Oh, yes.
It's a percentage. It's not the decimal.
Yes.
Yeah.
You're right. You're fantastic. It's the little words that you're able to see that makes a difference.
Yep. Like the little percentage there?
Yes.
Yeah.
I will be like, give me the decimal, give me the decimal.
This question,
Looking reference to the variable.
it's just asking for the standard deviation. Now the question is this a sample or a population?
Determine standard deviation. Okay, hold on, let me block and reference to the idea of the variable.
There's one important word in this whole sentence. What is it?
Sample.
That's right. This is a sample. 10 male and 10 female. Okay, what do they want? Determine the standard deviation of recumbent lengths for all 20 observations. So just click the thing. All we need is the sample standard deviation. So let's see if we can get it. It gives it to us like that.
Oh.
So how are we going to do it then? Because I don't think it wants us separately. It says all of them, right?
Is that what it says? Hold on. Send the length of samples, males and females.
It says determine the standard deviation of recumbent length for all 20 observations, right? So how do we do this? Let's see if we can figure this out.
So for all 20 observations, determine the standard deviation. So do I need to do where are those?
No, the calculator, StatCrunch will give you the standard deviation.
Yeah, but males and females, okay.
Click data.
Arrange.
Yeah, stack. Good job, teamwork. Now click them both. I don't know if this is gonna work, but I'm trying.
Okay.
Store variables in.
Store what?
Click that.
This one?
Yeah.
It's not giving me.
Never mind. Just press compute. There you go. Now just do it on variable 4. We have it all in one column.
Under options.
Oh no, we have never. So you can't do options edit because we haven't done summary statistics yet. It's only if you've done summary statistics where you can edit it.
Oh, I see.
Yeah.
Standard deviation, right?
Yeah. There you go. That's your answer.
You're making this seem like it's nothing. I don't know. I lost it. Where'd it go?
It's behind it, probably.
No, that's not what I want. Round to 2 decimal places as needed.
6.10.
How long did it take you to understand what all of this is?
Huh?
How long did it take you to understand everything that you're teaching?
I don't know how long. Couple, like 30 minutes, 40 minutes. I don't know. I'm just kidding. Well, I got my master's degree, so that takes like an extra. After you get your bachelor's degree, that's like an extra 3 years. So you go to school for like 7 years to get a bachelor's degree, then a master's.
Was it difficult for you?
Oh yeah, very difficult. Very, very difficult. Anything worth your while in life, it better be difficult, because if it ain't, stop.
Amen. Okay, so determine the standard deviation of the recombinant for the males.
I should take my advice on that sometimes.
Well, so I can just do, it's asking for the males.
Yeah.
So just do
So
now.
just go to options now?
I was going to edit.
Yeah, it'll probably work now if you change the males, yeah.
Okay, so it's 5 points. So how many? 66?
Yeah.
The fact that you taught me StatCrunch.
I'm glad I showed you StatCrunch.
Mhm.
Otherwise, we'd be here we would still be on 3.1.
Sorry. I will, yeah. 61?
Yeah. I wish you would have made this video earlier. You could have showed it to your classmates.
I know, right? What effect does blocking by gender have on the standard deviation for each gender? What effect blocking by gender?
Does it make it bigger or smaller? Let's see. I would assume that the standard deviation got bigger when you put everybody together, right? Would make sense that if you put people together, all the genders together, then the standard deviation is going to be bigger. But if you block them off, the standard deviation will get smaller. I'm guessing by blocking, does that mean like segregate by sex?
Up on the standard deviation. And the standard deviation for each group is the same. So it's lower.
I would say it got smaller, I'm guessing.
Mm-hmm.
Because I would just, if you're in your own gender, then you have less variability in the height, right?
Yes, that makes sense. The mean and standard deviation. Every time I see these questions now, I'm like, oh, I don't have to plug anything in. I just type in whatever.
StatCrunch.
I had no idea how much I was I was struggling with this stuff. Definition for each. Okay. Mutual funds.
But realize that it's easy because I'm with you. When you're by yourself, it's going to be harder. So you're going to have to kind of, it might seem easy because you have a crutch right now. You have somebody showing you, you know what I mean? Like, how good is your memory?
That's why I have to take notes. So we're going to do one. It was asking for, oh my God, what did it? See, I have a bad memory. Standard deviation. Okay. I only did one. I should have done both.
Is it a sample or a population?
This is.
I'm guessing it's a sample.
It's a sample.
Yes, randomly sampled.
Yep. Okay, for funds. Type in interest.
18 parts.
Huh? What?
This question has 18 parts.
Yes.
Wow.
See how they torture us?
I know.
Decimal places, isn't it? 3 decimal places. So 670?
3, yeah.
What?
It's asking for the mean.
What am I looking at?
We found the standard deviation. It's asking for the mean.
How did I? Oh, because I was only looking up here too.
Go to options and just push. Get it, yeah.
Um,
Excelente. Now, what does it want? The standard deviation?
it's the same, but for the stock. Wait, the standard deviation of the for bond. No, it's the standard deviation.
Go to options and then just click them both
You know, right?
and do the mean and standard deviation for both.
Standard deviation. Okay. What would I do without you?
Phil?
Assuming this is going to be the bond and the top is going to be the stock. True.
Yeah, bottom is stock, top is bond, probably.
So the standard deviation of the data bond from 0.67.
No, that's
Wait, what?
the stock. The top one's the bond, I think. It's 0.903. $903? Yeah.
I'm wrong. The standard deviation of the data set for the bond.
Oh, what? It's backwards. The variable one is on the bottom. So it's 0.6, 0.7, 0.670. Did you put that last time or what'd you put?
Isn't that what I just? Okay, so this is variable 1, which is the bond, correct? And this is the stocks. So bond and stocks. So this is the standard deviation.
0.670. Right?
0.6. Isn't that what I put the first time?
I don't remember.
669.
Oh, yeah. 669 works.
Why? Like,
We rounded wrong.
I rounded to the second instead of the third, huh?
Yeah.
Yeah.
We both messed up.
No, that was my bad.
It's all right.
You know the data
We
set.
still have an A.
The data set for stock mutual fund.
The mean of the stock mutual fund is.
So we said this. The bottom is the stocks now.
Yeah.
It's 3 decimals, so it's going to be 8.013.
Right.
Okay. Stock
0.903. Right?
0.903, yes.
Yeah. Can't believe there's so many parts to this question. It's insane.
It's torturous. And all the homework is like that. Like, there's a lot of questions that have like 16 parts, 12 parts, 10 parts.
Well, you got to be diligent. You got to work every day. In a summer class, you got to work like, let me think, 3 hours. Dang, my students are going to, like 7 hours a day. Yeah.
That's, I think that's as much as I...
Like every day. So 5 days a week or 4 or 5 days a week, you got to work 7 hours a day.
Yeah, he cuts it to working 4 days a week, but I'm assuming we have to do, 7 hours a week. That's a lot.
No, a day.
A day.
How long is your class?
It's 6 weeks.
No, every day. How long do you meet in a day?
Oh, we don't meet up.
My class meets for like 3.5 hours every day, Monday through Friday. So they need to be studying 7 hours a day.
See, we don't meet up, so.
But I'm saying that you should be studying 7 hours a day because it's the same class.
Yeah.
However many hours you meet, you're supposed to double that. That's how much you should be studying.
Yeah.
For every hour you learn, you're supposed to study that times 2. So a summer class is very, 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 you cannot mess around.
Okay. I can do this.
Based only on the standard deviation, blank, have more spread. Stocks, mutual funds. Stock mutual funds, I'm guessing. Is it bigger, the standard deviation?
Standard deviation have more spread.
Which one has the bigger standard deviation?
It's going to be the stock mutual.
Yep.
What proportion of the bond mutual? So that's the top one. Funds are within 1 standard deviation of the mean. What? What proportion of the bond mutual funds are within 1 standard deviation?
Oh, why in the world is this question even here?
Of the mean.
This is ridiculous. It's fun, but
What?
I can't believe this question is here. Like, who do they expect to actually get this correct? Not many people, but
What proportion of the bond mutual funds
are within 1 standard deviation of the mean. So the mean was what again? Let's find the mean and the standard deviation and find the range.
So the mean is 2.3 0.375.
So what I need you to do is add the standard deviation and subtract standard deviation from that mean.
So I'm gonna put 0.669.
9. Yeah, add that to 2.375 and then subtract that and tell me those two numbers. And write down those two numbers
At 2.375
plus 0.669.
plus 0.669.
Yeah.
Oh yeah. So 0.669 plus 2.375.
Yeah.
That gives me 3.044.
So write that down and then now subtract 0.669 from 2.375.
Oh.
And then write down those two numbers.
Okay. And then.
And now count how many of the stock. Now count how many of the bonds are within that range. So go to the StatCrunch again.
Oh, this one?
Yeah, it's over there. Yeah, go over there.
Can I do the option?
No, go to data and then sort.
Okay, so data sort.
I guess arrange, or is there a sort? And then variable 1 and 2, maybe do them both.
I'm gonna ask me for both.
Oh,
This and this. Okay. Sort by select.
actually, just click variable 1. Maybe don't click them both. I'm not sure how this works. This is weird. Click variable 2.
And remove. How do you? Okay, there you go.
Well, I think we want variable 1, don't we?
Oh, did I not? Oh, okay, there you go.
Okay, now try that.
We want ascending.
Yeah. Well, you replaced it. That's fine. Okay, we sorted it. Cool.
Replace. Wait, what did it do?
It replaced that, but it sorted it, right?
Yes.
So now count how many of those numbers are within the range of the two numbers you wrote down.
How many numbers? This is a lot of work.
I know.
Okay, so 706 to 3.044. So 1, 2, 3, 4.
What were the two numbers that you had?
I got 1.706.
Okay.
And then I got 3.044.
Can you write those on the cells? Just put them somewhere.
Like somewhere here?
Yeah.
0.6 and then 3 point. Okay.
Can you highlight the ones that are within that range? 1.6 is not.
Oh no, you're right. So it's gonna be yes.
Now hold down and scroll down. I don't know if you can highlight multiple cells. Can you? Maybe not. Never mind. I don't know if you can. So 1.8, 1.9, 2, 2.4, all the way to 2.7, or yeah, all the way to 2.7. So how many numbers is that?
5.
So 5 out of 8. So that's the answer. 5 out of 8.
They expect us to know this?
Yeah, it's kind of hard, or just a lot of work.
So it will be 0.625?
Yeah.
Oh wait. They always ding me if I don't do a 0. You make it look like it's nothing.
I know. That's
But
the problem.
I'm reading it and I'm like, what am I reading at?
That's the problem of having a tutor.
What proportion of the stock mutual funds are within one standard deviation? So I'm doing the same, but for the other one, correct?
Yeah.
Okay, no. Where's the other one? Did I close it out?
Probably. But you have to find the mean and the standard deviation first. We already found them, right?
We have. Okay, hold on. The mean for, wait, which one are we doing? The stock now?
Stock, yeah.
So this is the bond mutual stock. So it's going to be 8.013
Yep.
and 0.903. So that's the mean and the standard deviation.
Right. But you have to find the lower and upper bound now with those two numbers, right?
Oh, it's, so I do
The question says what percentage are within one standard deviation? Did you see that?
what proportion of the stock mutual funds are within one standard deviation?
Of the mean, right?
Yes.
So do you know what that means?
So I need to find within one standard deviation. Why do I feel lost again?
Because it's hard.
Spread. Okay. I'm lost again.
Yeah, within one standard deviation is,
We just did this.
yeah, you add and subtract the standard deviation from the mean.
I add and subtract the standard deviation.
From the mean.
Okay. And we said that my mean was the 8. Okay, so this is nothing. So let me add and subtract.
Yeah.
So it's going to be 7.1 or 11. And then it's going to be 8.916.
So write those numbers in the cells. Like type those numbers in.
8.916.
Can you make that text bigger by control?
It was a command? Or
Yeah.
control? Yes.
See if it works. A little bit bigger. Oh, that's cool.
That works?
Yeah.
Okay. And then if I want,
You don't need to sort it. It's already in descending order. It's already in order. So
it is.
so it's 7.2, 7.4, 7, 6, 8, 1, 8, 4. So that's 1, 2, 3, 4, 5. 5 out of 8. Same answer.
5. Say that one more time. You said 5 out of 8. Yeah.
Yeah.
It's 0.6. Oh. It's too complicated.
Boom, 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 boom.
Okay. 11 parts remaining.
Oh my gosh. The coefficient of variations. So just divide the standard deviation divided by the mean.
Okay, the CV allows. So this is going to be CV allows for a comparison and spread for describing the amount of spread. What is the CV of the data set for bond mutual funds? What did it say was my mean? Okay. 2.375, 0.669. And that's going to be my 0.669 divided by 2.375. Typed it in around 3 decimal places. 282. Yes.
Yeah.
Oh my gosh. I wouldn't have been able to do this without you.
Cool. Glad I can help.
The mutual funds, it's 6.0 divided by 13.
This is insane. The amount of freaking things that are covered here is insane.
Based on the coefficient of variation, mutuals, one mutual. Oh my God, I'm able to do some work after you taught me stuff.
What?
The fact that I'm able to do stuff after you taught me, I'm like, oh my gosh.
You
And get
learn.
correct.
I know. You're becoming a pro.
I don't know about that, but that is set on the left. That's the height of students measured in inches. Why are they making it so complicated?
I know. What are they giving people's height in inches and centimeters and wanting to see if the standard deviation changes depending on the type of measurement? That seems like a good question. I don't know what, maybe they're not doing that. They want the coefficient of variation for both data sets. Jeez. So they want the mean and standard deviation for both data sets, and they want you to divide them both. Wow.
That's a lot of work.
Maybe it does it. Maybe they have a CV in there. I doubt it, but.
Okay, so I'm going to continue to see the second. Okay, what is the mean of the data set for the height in inches?
Yeah.
Okay. I need to write my stuff down too. Don't worry, I'm not going to write the whole thing down. Okay. It's probably going to ask me for both, huh? I should just do both.
Maybe.
It's asking me for the mean.
If you want, you can say on variable 1.
Uh-huh.
If you could put height, or you could put inches and then cm. Like if you go to variable 1, on the very top you could change the label.
Here?
Put in or whatever. You put in and then cm.
For this one?
Yeah. You could change
that
the
way I
label.
can, February columns. And I want to do, it was asking me for.
Does it have a CV? I doubt it, but just want the mean and the standard deviation.
We're going to do the means.
And I'm assuming it's a sample, so we can just do standard deviation. Coefficient of variance.
Is it that one? No. Is it?
I don't think so. Maybe.
Let's find out.
Just find out. So the mean is 71, standard deviation 3. 71 divided by 3 is not 4, so nope, that's not it.
Because we're doing
The mean divided by the standard deviation.
divided by the standard deviation. Oh, yes, no.
You could do, if you go to, watch, try this. If you go to data, this might not work, but if you go to compute, expression, build, go to functions and put at mean, type in M on functions, try to find, does it have mean there?
Wait, this one?
Yeah, double click.
Okay.
Go to the first M and delete it.
Oh,
We go to build again. Just press back arrow. Wait, no, go to the right and then just press, yeah. And then inside of mean, put it, go in there, put inches in there. No, double click the inch on the IN.
Right here?
Yeah, double click. Double click, or no, it doesn't work.
It's not doing anything.
Cancel. Watch, go to watch.
Cancel again?
No, get rid of the first M. And then inside of the parentheses, put IN. And then go to the right. Press right arrow. Push divided by, the division sum thing. No, division, not multiplication.
All right.
And then go to standard deviation. Go to functions and go to S. I'm just curious if this works. Lower? Oh, wait.
Is it STD?
Maybe STD? Oh, dang. No.
Once I click it, I
You wait, scroll up. But outside of that, watch, click out of that. And then scroll up now.
it won't let me.
Press OK, I guess.
No.
After the right arrow, yeah. Put STD and then just put parentheses and then IN. See if this works. It might not work. I'm just curious if this will work.
And compute?
Yeah. And then close those. Close those.
Don't I eventually need this?
Later. I just want to see if this worked though. There it is. 20.67. Now, is 71.125 divided by 3.44 20.67?
So 3.44, right? 3.44.
No, 71.125 divided by 3.4408. Right?
Is that, are you sure?
The mean divided by the standard deviation? Isn't that what we were finding before? The mean divided by the standard deviation?
Yes.
So what do you get?
divided by 3.44,
0.8.
20.67.
Wow, so it did work to do it that way. Okay. Interesting.
Interesting. Wow. How did you manage to do this?
I don't know. Miracle. It was a miracle.
Wow.
So now we know how to get those things with the calculator or with that, with either way.
Why do I have, in order to get this CV, I have standard deviation over mean?
No. Mean over standard deviation.
Why do I have it? That's how I have it in here. Why?
You wrote it down like that, or where do you have it that way?
I wrote it down like I copied it from whatever I saw here.
Maybe you just copied it wrong.
I must
You
have.
scroll up right there. Look. Oh wait. Okay, you're right.
I'm always right.
Of course you are. So then we did it wrong. Okay. All right. So we have to flip that. We did it the other way.
Just flipping it?
Yeah, we don't need to do it. Whichever way you like better. You could do it on that way. You could do it that way. Whichever way you want.
But just the fact that it came up, it's just like, wow.
Yeah, you can do stuff on StatCrunch. You can do anything, apparently.
Okay. That's very interesting. Let's see. So
just do the standard deviation divided by the mean.
what am I doing right here? What is the means of the data set for the height? In inches, 71 point. 71 point what?
125.
125. Okay. The standard deviation. Maybe 3.44. How many 3? 1?
Yeah.
Centimeters.
Go to the top of that thing.
Go to the top of
The very top and move and drag that to the right because we don't need the coefficient of variation. There you go. Yeah, like that.
So for the height, so it's 1, 6, 6, 5, 8.
Somebody knows how to round.
That's what I've learned from you so far. 7, 3, wait. 740, right?
Yeah.
Definition, the data set for height in.
I'm guessing centimeters because the numbers are bigger.
Yes. I will agree with you. Those are small. This is C. Okay.
So
For
just
height
divide.
in inches, which was the top. What did we say was standard deviation over
Mean.
3.44 divided by 7 point. I don't know if I got this right.
Try it.
0 point. Oh, how many? 3. 8. You're amazing. You're a miracle worker. Has anyone told you that?
Few people. No.
Good. They should tell you more often. 0 divided by point. Why is it the same?
It could be the same. That's probably, maybe that's the point. That's interesting.
That is interesting.
Because they're both sort of changing together. The mean, and I was looking at that too. I was like, the standard deviation got bigger with the centimeters, and the mean also got bigger. So there's some sort of proportionality here. They're proportional. It's interesting.
The true coefficient of
Variation.
is always more meaningful than the standard deviation. Coefficient of variation does not give us accurate measurements. Coefficient of variation is best used when comparing two sets. To measure the coefficient of variation is unchanged.
D, maybe?
That's what I was thinking, because it.
That was kind of the point, right? What they were, it seems like that's the point they were trying to make, because it was the same, right?
Yeah.
Is it just choose one, or what do we, yeah, try it.
Just choose one, but this looks more.
That seems like what they were trying to do.
You've completed all parts.
Wow, we actually finished that question? I thought we never would. Jeez.
Okay, let's see what's the rest of it. Ah,
Jeez.
okay. Okay, so the standard deviation of the height of male was 3.5 inches. And the standard deviation for females was 3.1. Why is the standard deviation of the entire class more than the standard deviation of the males and females? Consider separately. Because, okay, the standard deviation of the entire class is more than the standard deviation of males and females. Separately, because the distribution of the entire class has more dispersion. Okay. And also consider separately because more dispersion. Examples. A sounds right to me.
All right, try it.
You made this. This is you. I'm serious.
Keep it coming. No.
Okay, so this I only have one final check. I can't check again.
Oh,
And this is the last question for this.
see if you got it.
If a variable has a distribution that is bell-shaped, where's my bell-shaped stuff? Okay. Bell-shaped. With mean 22 and standard deviation 6. Whew. According to them. Oh, I'm so bad at this empirical rule stuff. 99.7% of that will lie between which value? This is a question. Be certain of your answer because you only get one attempt. Should I look at my book?
I don't know.
So apparently,
We already talked about this question, so.
Yeah, and apparently, like this answers are in the book. Apparently, like this question's in the book. According to the empirical rule, 99.7% of the data will lie between. And this empirical thing, I have trouble with.
Right. It's called the 68.
So I do have 68, 95, 99.7.
Yeah, those three numbers refer to 1, 2, and 3 standard deviations.
According to the empirical rule, 99.7% of the data will lie between 1 and 3. Is that what it's asking? Because I mean, 99.7, it's 3. Not in between.
The answer is 4 and 40 because you add and subtract 18 to 22. Because 99.7 tells me 3. It's the biggest percentage, so it contains the most amount of data. Okay. So it has to be 3 standard deviations out. So I multiply 6 times 3, which is 18. Oh. So I add and subtract 18 to 22.
Because the 22 is the means. So you multiply 6 times 3, you said, right?
Right.
Just 18, and then you add and then subtract that from 22.
Right.
So, yeah, you're right. 4 and 40. I need to, sorry, I want to be, I'm going to take a screenshot of this because I want to. Good job. You're amazing.
So are you.
Thank you so much.
You're welcome. You got 11. What'd you score?
I got what?
Oh, never mind. You got a 99.54.
Yeah, that was the one.
Yeah.
The one.
The one that we rounded wrong on?
I rounded it wrong. That was my.
It was both of our faults. We were tired.
No, I appreciate it very much.
Yep. Get some sleep.
You too. I owe you 2 bottles of Coke.
Yep. Cool.
Red Coke.
Yeah, red Coke. Cool. All right, well, have a good night.
You have a wonderful night yourself.
All right, then. Peace.
Bye.
Bye.